What you're going to notice next, guys, is questions 13 through 16. There's going to be two symbols, and the two symbols are these two symbols here and this one here. Now, what this means is, if I go back to my software here, right? If I have a parallel line, 3 across, 3 up, yeah? And I draw another line with the same slope, these two lines will never ever meet each other. They are what are referred to as parallel lines. This symbol here. This symbol here. This should mean for this question that AB has the same slope as what? It has the same slope as CD. So, does it have the same slope as CD? That's what we're trying to find out. So, here's what we do. We find the slope of AB, so we use x1, y1, x2, y2. We use the slope formula, which is y2 minus y1 over x2 minus x1. I told you can do a really easy way where you just put everything in brackets like this, and then you can just put everything straight in, whether it's a minus sign or not. So I'll actually what I'll do, clone that and use it again. 1 second, sorry about that. There we go. I'm going to use it twice in this question, haven't I? So I'm going to start with the slope of AB. So the slope of AB is minus 1 for, 1 for y, y2, minus 3 for y1, minus 1 for x2, and minus 4 for x1. So put this in the calculator, fraction button, bracket bracket, minus bracket bracket, all over bracket bracket, minus bracket bracket. So I'll just go up and fill it in. So I have the number 1, and then I have was a minus 3, and then underneath minus 1, and then minus 4, isn't it? And then just press equals 4 over 3. So the slope of AB is 4 over 3. Next thing I'm going to do is the slope of CD. So the slope of CD, guys, x1, y1, x2, y2. 6 minus 2, and on the bottom 5 minus 2. This is a much easier one because there's no minus signs involved. It's going to get me 4 over 3. Slopes are the same, therefore it's parallel. Everybody looking at this? This is where we start to get stuck now, okay? Every year. Now, we go to the same one. We go to a new question, which is question 15. Okay, so question 15, okay? So I'll just go back here. I'm going to do the same, more or less the same procedure again. I'm going to get the slope twice. Now, when an object is this, like question 15 goes, these are 3 points, prove that xy is parallel to zy. Do you know what that looks like? Perpendicular. That means something like this. It hits it at 90 degrees. Now, I have something interesting for you, okay? Go to this last diagram here. Now, let's say I pick a line to draw. So, if I pick a line to draw, something like this, a slope of 2, let's say, 1 across and 2 up. Everybody happy with that? Now, I want to get something that's 90 degrees to that. You have to do the exact opposite. So, if one of them's a positive slope, the one that's going to be perpendicular to it has to be a negative slope. Would you agree with that? If one of them's positive, the other one's going to have to be negative. Now, negative by how much? Let's try 2 down, 1 across. What do you think? No. Let's try 1 down, 2 across. Now, believe it or not, that's dead on, even though it may not necessarily look it. That is 90 degrees. So, what we learned from here is that when you have a slope of example, this is just for the example I showed you a second ago, the slope is 2 over 1. The perpendicular slope is turn it upside down and change the sign. So minus 1 over 2. If the first slope is positive, the second slope must be negative and turned upside down. That brings us to this point here then, okay? If this is correct, we'll find that one of them is the upside down version of the other one with the sign changed. Let's find out. So x1, y1, we need to find xy, x2, y2. Put in your numbers. Minus 1, minus 4, 8, take away 7. It's 1 on the bottom, and on the top it's going to be 3. 3 over 1, same thing as 3. Now, if we go back to this diagram, I'm going to draw in a slope of 3. Slope of 3, guys, is 1 across and 3 upwards. Yeah? A perpendicular slope to that, 1 down, 3 across. So we're expecting minus 1/3 if this is to work properly. Let's find out. So in the second part of the question, it asked me to find out the slope of ZY. I've already found out the slope of XY. Now I'm asked to find the slope of ZY. So rub it out here. ZY, relabel. X1, Y1, X2, Y2. Minus 3, take away. Minus 1, 1, take away 7. I'll use the calculator for this one. Go back to the start, press the fraction button, bracket, bracket, minus, bracket, bracket, and then bracket, bracket, minus, bracket, bracket. Now, let's just fill it in then. It's really easy. Minus 3, and then the other one, minus 1, then on the bottom. Now, if we've done this right, it should be minus 1/3. Plus 1/3. Now, pause for a second. So guys, this here is 1/3. Now we're expecting that to be minus 1/3, which means we made a mistake, okay? The mistake was made over here. If we go back to the original one, we made this here, we made this x2, y2, which makes this x1, y1. Now look at it, okay? y2 minus y1 is perfect, but it should be 7 minus 8, not 8 minus 7. So that should be 7 minus 8, which makes it a slope of minus 3, and the other slope will be 1/3. So does everybody get that? It's always whatever sign it is, turn it upside down, change sign. Now you have to do one last thing to make sure that they're perpendicular, and this is where all the marks go. You got to write down m1 multiplied by m2 equals minus 1, and you have to do this every time. You have to get the slope of the first one, which is minus 3. Get the slope of the second one, which is 1 over 3. Now what happens when you multiply minus 3 by 1 over 3? Sorry? You're going to get minus 1. Okay? And what happens there is you get minus 1. And then when you write down minus 1 equals minus 1, that proves they're perpendicular to each other. Okay, what's that? Question 15.